Hello everyone, thank you for taking the time to join today's webinar, Electrical Installation for Potentially Hazardous Areas, the Importance of the Initial Detailed Inspection. A recorded version of the webinar will be available to you along with a copy of the slide deck. We'd love to hear from you, so please submit your questions at any time during the webinar. You can find the Q&A panel underneath the video feed and your questions will not be seen by any other attendees. We'll do our best to answer as many as we can, but if we do run out of time, we will follow up any unanswered questions. So, a couple of introductions. I'm James Gardner, Internal Sales Executive for the Machinery Division here at Tufsud. I've been with Tufsud for 3 months, having recently joined from another company in the product compliance industry. I bring with me a wide-ranging knowledge base of the compliance industry, as well as a proven track record of providing a first-class experience for my clients. Today, we will be discussing the electrical installation for potentially hazardous areas. Poor installation can compromise the integrity of EX equipment. Conducting initial detailed inspections of EX equipment prior to first use will help to identify potential installation quality issues, as well as ensuring the equipment is suitable for use. This webinar will give you a detailed overview of this topic and how Tufsud can help you. Our presenter today is Stephen Lang, EX Protection Technical Advisor. Stephen joined Tufsud in 2021. His previous roles have been within the oil and gas construction industry, most recently with McDermott's PTI Asia Pacific, on the Total Tyra redevelopment project. Prior to that, Stephen was with BP's Global Projects Organization on the Shah Deniz B in Azerbaijan and Clare Ridge in Korea. His background is in instrumentation and he has become more focused on ATEX standards and EX inspections. He hopes to use this experience to try and open up new opportunities for Tufsud in the area of EX inspection, maintenance and management. So I'll hand things over to Stephen, who will now present the webinar.
Thanks, James. The presentation is about the importance of initial detailed inspection. It's a brief insight into the importance of initial inspections. And the presentation is focused primarily on UK scope and legislation. Why do we inspect? The simple answer is that it's embedded into legislation. The requirement to maintain plant and equipment in good working order is detailed in a number of legislations and directives. Inspection and maintenance is the best way to ensure the integrity of plant and equipment. The point of the legislation and regulations and directives shown below is to allow the use of electricity in potentially explosive atmospheres. Not all are listed, for example, the offshore installation cases. A point often overlooked is that inspection before first use or delivery, as well as looking for safety issues, can also save money and reputation. The photo in this slide is a general photograph showing some poor landing. In this instance, the supplier had to fix this and many other issues at his own cost. First piece of legislation is the Health and Safety at Work Act 1974. This primary piece of legislation covers occupational health and safety at work in the UK. Among the duties it places on employers, safe provision and maintenance of plant and systems are detailed within. Employees' duties, as well as taking a proper interest in activities and methods adopted by their contractors, should be able to be competently select, specify, audit and review their work. The Act also places general duties on equipment and manufacture concerning design, construction and operation. The general duties that it places is that their equipment is safe to use as far as reasonably practical. The photograph in the slide, whoever installed this light modified the casings in the hanger for the gland. The gland was installed but was oversized. The certification for the light was invalidated due to the unauthorized modifications, and the EX integrity of the unit was compromised. It was potentially dangerous. In this instance, there were several lights all installed like this. An initial inspection would have picked this up, but of course, at that point, the damage was done. The manufacturer had supplied a product that was, as far as reasonably practical, safe. The employer, however, did not take an interest in his contractor's activities, nor did they audit or review. Provision and Use of Work Equipment Regulations 1998. The Provision and Use of Work Equipment Regulations (PUR) imposes absolute requirements on employers to ensure that work equipment is in an efficient state, working order and in good repair. PUR applies to all EX equipment and in practice it requires all equipment, including EX equipment, to be inspected, maintained such that it meets the original certification requirements. This installation in the photograph was picked up at a factory pre-FAT AEX inspection. The certificate for the gland states, cable gland is intended for use with an effectively filled, circular, armoured or braided cable, one cable. It also lists the components contained within the gland, which in this case have either been not used or discarded. Thankfully, this was rectified at the supplier yard prior to shipping at their cost. The Electricity and Work Regulations, 1989. The Electricity and Work Regulations, EAWR, covers the requirements of electrical systems, work activities, protective equipment, and the effects of adverse or hazardous elements, i.e. the use of EX equipment. It places duties on employers as well as an onus on the employee to cooperate to enable compliance, thus ensuring the safety of the installation and those who work on or near it. It requires that persons working on equipment are competent to do so in order to prevent dangerous situations or injury. Competency can be measured by experience, training, and certification. The photo inset, given the type of glands used, the barrier glands, and the cables being used, the competency of the installer was under question. Again, the gland certificate will state the type of cable accepted for use, as well as detailing minimum and maximum cable ODs. The gland also has components for use in this installation. They would not have been used given the size and type of cable. The ATEX Workplace Directive, ATEX 153. The ATEX User Directive and the Chemical Agents Directive 98/24 form together to make DCIR. The ATEX Workplace Directive places the onus on the plant operators and owners and is implemented by DCIR in the UK. The Dangerous Substances and Regulations Act, Explosive Atmosphere Regulation 2002, DCIR, is law. It requires the classification of areas where flammable zones may occur into zones. The ATEX Workplace Directive, definitions for potentially explosive atmospheres. Zones are areas of risk, 202122 for dust or 012 for gas and vapours. They detail the probability, frequency and duration of a hazardous atmosphere being present in normal operation. That being continuous, long, likely, not likely, short. It is probability, frequency and duration. The image shown in the slide is of an uncertified solenoid located within a Zone 1 area. The ATEX Equipment Directive. The ATEX Equipment Directive focuses on the manufacturers and their responsibilities. It is implemented by the Equipment and Protective Systems, the EPS regulations in the UK. The Equipment and Protective Systems intended for use in potentially explosive atmospheres regulation 2016 is law. The EPS regs require that equipment protective systems intended for use in an explosive atmosphere meet essential health and safety requirements before being placed on the market. Usually involves testing or certification by a third-party body or notified body. Self-certification is possible under certain circumstances. Certification of conformity confirms that it meets regulations. It certifies that the equipment design conforms with the essential health and safety requirements for each category. The definition of equipment is machines, apparatus, fixed and mobile devices, control components and instrumentation thereof detection and prevention systems, which separately or jointly are intended for the generation, transfer, storage, measurement, control and conversion of energy or the processing of material which are capable of causing an explosion through their own potential sources of ignition. After installation, how is confirmation that certification is achieved and maintained? The JB in the photo at first glance looks okay. A detailed inspection found 2 unauthorised modifications. An unauthorised modification essentially invalidates the certification. This was picked up at a pre-shipping inspection at a supplier yard. The cost and time involved in replacing its site would have been high. The ATEX Equipment Directive, the equipment groups in conformity categories. The ATEX Equipment Directive, the three equipment groups are broken into 5 categories. The categories are the level of EX protection required. Equipment protection systems conformity assessment details the level of protection. Very high, 2 independent protection methods, safe with 2 faults, high, safe with 1 fault, and normal, suitable for normal operation. EX equipment is certified as meeting essential health and safety requirements. Plans complete the integrity of EX installations or the integration of equipment into an installation. Manufacturer installation instructions will detail earthing and glanding requirements which can help with stray earthing issues. Poor glanding, such as seen as the photo, or earthing can compromise this. Connection between the ATEX directives. This diagram shows the integration between the directives. The user directive classifies the zones and identifies which product category can be used in each zone. The equipment directive certifies the equipment design against the essential health and safety requirements for each category of protection. Zones define the probability, frequency, and duration of the occurrence of a potentially explosive atmosphere. Categories define the level of EX protection required. The installation in the photograph is a good example of the levels of EX protection required for a specific zone. The factory had, after being made aware of a zoning requirements in an extraction system, replaced non-certified fans and motors with certified units. No attention had been paid to the non-certified isolators located within the zoned areas. Reliance was left upon an installer without the correct knowledge base to carry out the work. Control of Major Accidents Hazard Regulations 2015. The aim of COMA is to prevent and mitigate the effects of major accidents involving dangerous substances. Operators must produce a major accident prevention policy, or a MAP. Prevention and mitigation against accidents can be provided by EC and I equipment and systems. This includes prevention against electrical sources of ignition. SMS safety management systems detailed within COMA states. Active monitoring should include inspections of safety critical plant, equipment, and instrumentation, as well as assessment with compliance and training. The HSE Competent Authority Delivery Guide, Inspection of Electrical Control and Instrumentation Systems at COMA establishments, details how the competent authority inspects EC and I aspects at COMA sites. This guide includes and lists all the benchmark standards used in doing this. Among the many standards listed, BS-EN 6007914, Design, Selection, and Erection, and BS-EN 6007917, Inspection and Maintenance are included. The light fitting in the image had one certified plug fitted. The yellow plug is a shipping plug. It confers no protection in line with the certification for the fitting. The installer went to the trouble of fitting one plug, yet left the shipping stop and spare entry hole. The light was never inspected after the install. The factory were unaware of the requirements or functions of the type of EX protection confirmed by the light. They relied on an installer who did not possess the relevant knowledge of installation standards. IEC ENBS 60079 Design Standards. The International Series of Standards, specifically 6007917, which contains information on the maintenance and inspection of EX equipment. The requirement to inspect is detailed in 6007914. Standards, harmonised, designated standards, or otherwise are known as recognised good practice. They are used as benchmarks for regulatory authorities and auditors such as the HSE. The importance of the initial inspection. VSEN 6007914 states the requirement for carrying out an initial inspection, the grade being detailed as per Annex C listed in 6007917. Other inspection types are periodic, continuous, and sample. The grades are close and visual. The purpose of the initial inspection is to ensure that the equipment or system has been installed as per the documentation. Initial inspection should encompass the physical installation as well as a check of engineering documentation. The documentation should be included to the master dossier. The detailed inspection and testing should be in accordance with IEC 60364-6. BS EN 6007917 supplements the requirements of this. The photograph shows a limit switch pickup on an initial inspection pre-factory acceptance test at a supplier facility. A spare core was cut and hidden in the housing. No crimps have been used. 6007914 states, multi-stranded cables shall be protected against separation of strands on termination. The repair required a new cable to be installed. This would have been costly and time-consuming had it been carried out at the project site. An initial inspection is critical to verify the integrity of the installed equipment and thus ensuring the certification requirements have been maintained. Suppliers spend thousands on certifying their products to ensure safety and compliance. If the installation is poor, this can be potentially undone. Certification could be compromised based on the quality of the installation, and that becomes the onus of the owner. This installation in the photograph had never been independently inspected. The uncertified junction box located in a hazardous zone contained barriers for an IS system. No IS loops existed. No IS earthing was evident. It was potentially unsafe. New installations within hazardous areas must be installed as per criteria laid out in the documentation. These documents, such as standards, specifications, certificates, and user installation instructions. Descriptive system documents, hazardous area drawings, loop drawings, detailed installation drawings, user instructions, certificates are all such documents. The correct documentation must be available to conduct the initial inspection. A detailed inspection at a supplier factory picked this fault up. The terminals installed within the EX connection box did not match a general arrangement layout, nor the wiring diagram. The installer, rather than query it, made his own links and altered the design. No management of change nor query was submitted. The modified crimps were not fit for purpose, and the solution was not within specification. The supplier had to redo the junction box as per design at his cost. An assembly may have multiple items of certified equipment incorporated within it. An assembly may be a skid base unit with integrated equipment fabricated by others for incorporation into a larger system or plan. The assembler then assumes the role of manufacturer. It becomes their responsibility to ensure certification and compliance with local legislation such as ATEX. Carrying out detailed inspections at subcontractor or fabricator facilities can unearth many costly or potentially dangerous issues with poor installations. If it is not done satisfactorily, it can create major problems for end user clients during commissioning or startup. Delays in project startup or commissioning over compliance issues can be costly and involved. The installation in the photograph was picked up in a detailed inspection at a fabricator yard prior to shipping to end user client site. Repair at site would have been time consuming and costly. A new cable was required, as not only the inner core insulation was damaged, the cable crutch was cut too short after the gland, and no spare length was available on the cable. The user installation supplied by the gland manufacturer details correct usage. Getting it right first time. Involving competent people in the early stages of design and procurement can help to mitigate EX compliance issues. Ensuring that design specification and purchasing specifications are clear and that the supplier and installer knows exactly what they are tasked with delivering is key to ensuring safe and successful delivery of EX installations. Specifying scope and required level of competency is important. The manufacturer of the EXD unit in the photo has taken steps to design and have certified a product. The installer has not shown an understanding of either the standards or project specifications. Note the spare cores taped and coiled within the unit. nor has he ensured that the equipment was preserved, taken care of, while in his facility. Note the rust on the flame path. Some simple checks prior to the install would have mitigated the additional scopes of replacing a full new cable. A competent designer would ensure that the cable supplied had the correct number of cores. A competent installer would have queried the additional cable cores and not just taped them up, hoping no one would notice. Ensuring competence with installers is the best way to ensure quality and compliance. Ensuring competency with installation personnel is as critical as carrying out inspections. Once again, this photo, cable type, gland selection are an issue. The installation was found during a pre-FAT EX inspection, and again, had to be rectified at supplier cost, thus saving time and money on the project. Competent inspectors will verify installation prior to first use. Having inspections carried out by competent inspectors is belt and braces practice. The installation in the photo was a 240-volt lighting circuit internal to a package due for shipping to a major project. The supplier had mistakenly identified the fire barrier on a fire-resistant cable as a screen. The cable was supplied as a flying lead on a mountable light. He had installed the instrument cabling for the remainder of the lighting circuit to the switch and left the shields floating in the junction box. Note damage to terminals and oversized crimps. The installation was rectified at supplier cost prior to shipping to site.
Brilliant. Thank you,
Any
Stephen.
questions?
We've got a couple of questions here, so I'm just going to go ahead and ask those. Okay. The images in the presentation are all showing non-compliant and some very poorly installed installations found during inspections. In your experience, do you always encounter issues with inspections?
In my experience, there's always something. At first glance, an installation may look good, but once you scratch the surface, you will always find things. A good inspector will always find something wrong. It's the photos were a collection of some of my own inspections and some gathered from friends and colleagues. Some of them were chosen because they were pretty bad. Some of them are less exciting.
Okay, awesome. So, question here: does TUVSUD carry out installation works, minor repairs, or reworks of EX equipment?
No, that's not in our scope of work. However, we can manage and oversee contractors or installers and manage EX compliance, as well as overseeing liquidate punch lists and carryover works. This is something we're actively promoting.
Brilliant. Third question. So, are TUVSUD able to audit suppliers or contractors?
Yes. This is something we can carry out with regards to EX scopes for both installation and engineering.
Okay, awesome. And I think probably the last question we've got time for. So, would TUVSUD be able to manage the ongoing EX maintenance and inspection and compliance on small or large sites?
Yes, this is something we're well positioned to carry out either by internally. We've also got the ability to hire in inspectors for large or small jobs if need be.
Brilliant. Okay, well, I think that's all of the questions. So we will round up here. Thanks again for joining us, everybody. Hopefully you found the webinar informative, and hopefully it will help you see the importance of the initial detailed inspection. As I mentioned earlier, we will be sending you a copy of the presentation and recording. Please get in touch to let us know if there are any webinar subjects you'd like us to cover. It's great to hear exactly what you're interested in hearing about. Feel free to get in touch with me about anything, whether it's regarding this webinar or not. My email is james.gardner@tuvsud.com. So on behalf of myself, our presenter Stephen, thank you for your time and enjoy the rest of your day.